Before we get into looking at the structure of databases, we need to differentiate between kinds of database management systems. You'll notice the rather formidable looking acronym in the corner here, RDBMSs. That stands for Relational Database Management Systems, which poses the question, what is a relational DBMS? To answer this, let's take a look at a practical example. Let's say we run a shop and we're storing our data in some kind of a table form. We need to know when people come in what they've bought, so that because our shop uses credit in our hypothetical example, at the end of the month or whenever we need to settle our accounts with our customers, we know exactly what they've bought. Let's take a look at the way this tab is used. We have a customer and a product column in our table. John Bull comes in and buys some beef. Felicity Pingle buys some tofu. And Charles Windsor pops in to buy some venison. Now, our system at the moment is similar to a flat file database system. Essentially, there is nothing in this system that couldn't be done by a card index. Each of the columns stores all the data, so that when John Bull comes in to buy some bread, we have to write his name down again. Now, there's an obvious disadvantage to this when we're applying this to a computer, that we're wasting space on the hard disk by entering the name John Bull twice. This may not look very serious when we have a list of 4 or 5 customers, but when we're dealing with a lot more high-end applications, then the implications become more severe. However, this is not the main problem with this system. The main problem is that it allows all kinds of errors to completely screw up our data. For instance, if when John Bull enters the shop, a new person is working behind the counter, they might not know John Bull. They might have to ask him for his name. They might mishear it, and instead of John Bull, they hear John Ball. Later on, when we try to run a query to find out what products John Bull has bought from us, the only one that will be beef, because the computer isn't intelligent enough to recognize that John Ball is just a misspelling of John Bull. Computers are very literal, and they can't fathom any kind of rational correlation between things. They only look at values being identical or otherwise. So our system is seriously flawed. If we replace this with a relational scenario, then we have a much different and more flexible system that has much less scope for that kind of error. What we do is we separate the customers into one table and the orders into another. When each order is placed, use a relationship between the orders table and the customers table to determine which of the customers made the order. We'll look at exactly how this happens much later on. For now, the important thing is that the data for the customer is stored once, and that when the shop attendant goes to write down the details of the order, he or she will look up the name of the customer in the customers table. Won't just write down the name of the customer from being told by the customer at that particular point. So John Bull bought the beef, Felicity Pingle bought the tofu, Charles Windsor bought the venison, and then because the shop attendant is not writing down the name but simply referring to the entry already in the customers table, there's no chance of an error. John Bull is connected with the bread order as well. So we can see that this is a much more effective system than the flat file system we examined before. In our next movie, we're going to take a look at the ways in which a database is actually structured.